Now we're going to get into chemical nomenclature, which is how chemicals are named. This is one of my favorite topics in General Chemistry 1 because this really starts to get into the language of chemistry and allows us to express ourselves as chemists. So we're going to start with naming ionic compounds. So molecular and ionic compounds are named a little bit differently, so we're going to look at them separately. So there are two different things we have to consider when we are naming ionic compounds, because ionic compounds can be named one of two ways. So we're going to start with the first type, which is ionic compounds that are made of metals that form only one type of cation. So which metals form only one type of cation? We have to take a look at this. And it's going to be the metals that are in groups 1 and group 2. So it's going to be this group here, so that's group 1. And group 2. So these are the metals that form only one type of cation. Notice how hydrogen is not considered a metal. So the group 1 metals are going to form a +1 charge. Group 2 metals will form a +2 charge. There are other metals on the periodic table, but we're going to look at that next. That is going to form our second type of ionic compound. So this is for type 1, metals that form only one type of cation, so this is things in group 1 and 2. And these metals form what are called binary ionic compounds. Take a look at that name. What do you expect binary ionic compounds to be? Well, binary means 2, so these are going to be ionic compounds that are formed of only 2 types of elements. So these are going to be our ionic compounds that are formed between a metal and a nonmetal. And here's what you do to name these. So this is the rules for naming binary compounds. We're going to start with the name of the metal, which is our cation. And then we're going to use the base name of the nonmetal, which is our anion. And we're going to talk in a moment about what the base name is. Some of you may be familiar with acids and bases. That's not what we're talking about here. When we're talking about the base name of nonmetals, we're talking about the root of that word. And then we add the suffix IDE at the end. So for example, I don't know why it keeps doing that, I apologize. Anyway, for example, if we have KCl and we want to write the name of this binary ionic compound, we're going to start with the name of the metal. Remember, the metal comes first. And K is the chemical symbol for potassium. And then we use the base name of the nonmetal. So Cl is our nonmetal. That is chlorine. And the base name of chlorine is CHLOR, chlor. And then we add IDE at the end. And it looks like that got deleted a moment ago. So the name of this compound is going to be potassium chloride. So these are all of the base names of the anions that are going to be most commonly used in this class. And you're going to need to memorize this column here. So those are the roots of each of those element names. And so notice how how you take the root and then you add IDE to the end. So for um, example, for floor, you have the root floor and then you add IDE. Chloride, bromide. Okay? So the one other thing I did want to direct your attention to is the spelling of all of these. And yes, in my class, I do grade on spelling for chemical names, and the reason is because when you start naming more and more complex chemicals, sometimes the chemical names between different compounds can end up being very similar. And even just one or two incorrect letters could signify an entirely different chemical. And it's very important that when we're working with chemicals, we know exactly what we're working with because it can be very dangerous if we think a chemical is one thing and it turns out it's really something else. So again, spelling is actually important here. So again, for this class, I want you to memorize those roots because we are also going to use them not only for naming anions, but also later on. So let's do a little bit of practice here. So I'm going to give you 3 chemicals. I'm going to give you the chemical formulas, and I want you to write the names. And you can pause the video once I write these and try to solve them on your own, and then see if your answers are correct. Okay, so let's solve these problems now. We're going to start with the name of the metal. So Ca is calcium. Then our nonmetal is Br, that's bromine. The root of that is brome, and then we add ide. For the next one, Ag, that one's actually really confusing because the name doesn't correspond, the name in English doesn't correspond to the chemical symbol. So Ag is actually silver. And you might say, oh, wow, there's something wrong here. Silver isn't a group 1 or a group 2 metal, and you are correct. So silver is one of our exceptions here. Technically, it is a transition metal, but there are a couple metals that actually form the same cation every time. One of them is silver. So silver always forms Ag+. Another one I want you to know is Hg. Hg is known for forming 2+. And another one that I want you to know is Al, aluminum. And Al is known to form a 3+ cation. So those are a couple extra ones, a couple exceptions to our group 1 and 2 rule. And these ones are going to be some of the ones we come across more often in this class. So we have our silver, Ag is silver, and then N is nitrogen, the root is NiTr, we end up with IDE, silver nitride. And finally, we have magnesium. Cl is chlorine, so that's going to form chloride. So next, I'm going to give you some chemical names, and I want you to write their formulas. So the first one is rubidium, sulfide. And the second one is sodium iodide. Okay, go ahead and pause your video here if you haven't already, and try to solve these two on your own. So first we have rubidium. So rubidium is Rb, and we know that sulfur is S. And in order to write these chemical formulas, we have to figure out what are the charges on this metal and the nonmetal. So we can go back to our periodic table and find rubidium. Rubidium is here, number 37. That is in group 1, so that's going to form a 1+. Sulfur is over here on this end. Remember that when forming anions, group 7 forms -1, group 6 forms -2, group 5 forms -3. So sulfur is going to form a -2 anion. So we have 1+ and 2-. We're going to flip those charges just like we saw in a previous video. And we're going to get Rb2S. And that is going to be the chemical formula for rubidium sulfide. Next we have sodium iodide, which is Na and I. So we'll go back to our periodic table. See that Na is also in group 1, and iodine is in group 7, so we have a +1 and a -1. So I'm just going to write plus and minus. So sometimes you'll see it as 1+, sometimes you'll see it as just a plus sign without the 1. Same thing with the minuses. Either way is correct. Most of the time, especially in professional scientific literature, you're going to see it without the 1 written. So we flip these charges, assuming that they are both 1s. And again, we don't usually write the 1s as subscripts, so we will end up with NaI, and that is going to be our chemical formula for sodium iodide. So that's the first method of naming ionic compounds. The second method is going to be used for metals that can form different types of cations. So this is the method that we're going to use whenever we have a transition metal. And the transition metals are in this middle part of the periodic table. So the transition metals are in general this whole block here. Except for a few exceptions that tend to form the same type of cation every time. So basically, whenever you are trying to name a chemical, I want your first step to be, is it a metal and nonmetal? Or is it a nonmetal and nonmetal? If it is a metal and a nonmetal, the second question that I want you to ask is the metal a transition metal? Because if it is, we're going to have to be much more specific about the charge. So for the most part, we name these in the same way, except we have to specify the charge of the cation. And that's because transition metals, they really kind of just like to do whatever they want. They're really cool and very interesting, and they can do some really awesome chemistry that's really useful for a lot of different industries in our society, but it does make naming them a little bit trickier. So I'm going to give an example here of iron. Iron is Fe, and it can generally form two different types of cations. It can form a 2+, and it can form a 3+. So those are the most common charges for iron. When we want to write the name of an iron compound, we have to include the charge in parentheses in Roman numerals. So the way that we would name this is iron 2, and this one would be iron 3. So notice that the Roman numeral does not tell the number of iron atoms we have. It tells us what the charge is. So how do we know what the charge of the cation is if it's not told to us directly? Like in this case, I just told you what it is, but that's not always the case. So when you don't know, like when the problem doesn't tell you exactly what it is, you have to use the ratios of the different atoms in that compound. So for example, if we have Cr, Br3, so we know that bromine is a 1-, that's in group 7. So we know that we have Br-, and we have Cr. Cr is a transition metal. If we look at our periodic table, it is right here, number 24. So that's right there in that what we call the D block, where the transition metals are. So we know we need to use the Roman numerals, but we don't know what the charge is. So we know it has some charge. We don't know what that charge is yet. So we have to think back to our rules for ionic compounds. Remember that one of the rules for ionic compounds is that the positive and negative charges have to balance each other out. Well, we know we have 3 bromines. That's what this 3 means. So we know that we have 3- charge for our anion. And we know that it has to balance each other out. So we know that in order to have 3-, we have to have 3+ on our cation side. So that means that our charge of the Cr has to be 3+. And we can go back and check our work. So we can try Cr3+ and Br- and flip our charges down to the bottom and make sure that we end up with the same thing that we started with. So Cr, Br3, that checks with the problem that we were given, so we know that we did that correctly. And now how would you name this, just for some extra practice? We know that that first element, our metal element, is chromium. That's spelled like this, Chromium. And again, it's a transition metal, so we have to use the Roman numerals. So we have chromium 3, because it's a 3+, bromide. And the anion part is named exactly the same way as it is even with a group 1 or a 2 metal. So let's do one more practice. Let's say you have CuO. Cu is copper, O is oxygen. We know that O is in group 6. It's going to form O2-. So we're going to have some charge on our copper. And we have an O2-. We know we only have one of each, So whatever the charge on the copper is has to balance out the charge on the oxygen, which means that our copper has to be 2 plus, which means that the name of this is going to be copper 2 oxide. Copper 2 oxide.